Selection sort is an algorithm that sorts a list by finding the smallest value of an item within a list and swapping it with the item just right of what has already been sorted. As a result, this sorting method sorts from front to back, where we'll see the beginnings of the sorted list on the left and the unsorted on the right. Let's get into more detail with the demonstration. This is a perfectly organized stack of cards. Now it isn't. For this demonstration, the card with the star is the card that may get swapped if a lower value is found. The star card is always the card just right of the sorted list or the first unsorted card. The green arrow represents the minimum. More likely than not, it won't start on the actual minimum. This can change multiple times throughout a scan. The red arrow is a visualization of the scanning process. It will always run through the full list, unlike the minimum arrow. In this random list, the minimum element we start with is 11 because it is first. However, as we go along, we see that 11 is not actually the minimum, since 2 is less than 11. The algorithm still goes through the entire list though. When it is sure that the lowest value of the list has been found, it swaps with the first. This is the beginning of the sorted list. Now we continue. Since 2 is sorted, we set 11 as the current minimum again, and scan the rest of the list, updating the minimum as we go along. In this case, we find 5 as the next minimum, which means it will swap with 11. Now we have 2 numbers in our sorted section. 11 is the starting minimum again this time around. The algorithm scans the list yet again, desperately searching for a number less than 11, and it found 6 at the very end. 6 is the new minimum and the last number in the list, so the scanning stops and the swapping happens. Unlike the previous runs, 11 is sent all the way to the back to replace 6's spot. As you can see, we're halfway through sorting this list. For this iteration, we start on 13 and scan the remaining numbers. Because the remaining numbers are in descending order, the minimum will be updated with every scan. Again, the lowest value is found at the end of the list, 11. 13 swaps with 11. At this point, we can see that the list is now perfectly sorted, but the algorithm still needs to run through the last loops and scans. Since 12 is still technically considered unsorted, we start there. The scan finds no number lower than 12, so no swap happens, and 12 remains in place. Except now, it joins the sorted club. 13 is the last item in the list, so there isn't even something we can compare it to. That's okay though, since if the algorithm did its job properly, the last item will always be the largest. Now we officially have a fully sorted list using selection sort.